Okay, welcome back to our second segment on the series of video lectures on database system concepts and architecture. Let's proceed. Many data models have been proposed which we can categorize according to the types of concepts that they use to describe the database structure. High-level or conceptual data models provide the concepts that are close to the way many users perceive the data, whereas low-level or physical data models provide concepts that describe the details of how data is stored on the computer storage media, usually a magnetic disk. Concepts provided by low-level data models are generally meant for computer specialists, not end users. Conceptual data models use concepts such as entities, attributes, and relationships. An entity represents a real-world object or a concept, such as an employee, or a student, or a course, or a class, that is described in the database. An attribute represents some property of interest that further describes an entity, such as the student ID number or the student's first name and last name. A relationship among two or more entities represents an association among the entities. For example, there could be a relationship called work zone between an employee and a project, or a relationship called taste class between a student and a class. The entity relationship model is a popular high-level conceptual data model that we're going to be discussing in some detail. Relational or implementation data models are the models most often used in traditional commercial database management systems. These models include the widely used relational data model, as well as the so-called legacy data models, the network or the hierarchical data models that have been widely used in the past. The relational data model was proposed by E.F. Codd in 1969. That's E.F. Codd, C-O-D-D. Let's make Codd our mystery word for this episode. It was created as a method of structuring data using relations. The object data model is an example of a new family of higher-level implementation data models that are closer to the conceptual data models. A standard for object databases called ODMG Object Model has been proposed by the Object Data Management Group, ODMG. Physical data models describe how data is stored as files in the computer by representing information such as record formats, record orderings, access paths, and so on. An access path is a structure that makes the search for a particular database record efficient. An index is an example of an access path that allows direct access to data using an index term or keyword. It may be organized in a linear or hierarchical structure or some other fashion. In the early days of the microcomputer, many of us used a database software package called DBase. DBase was an excellent database that I used to create a pretty good number of applications. A file that one would create in DBase, let's say an inventory file, would store new records in sequence. When one added a new record, it was simply put at the end of the file. The user could easily search for a record using any data element or attribute or field in the record. But unless the file was sorted by that data element, it would just do a sequential search. That is to say, it would start with the first record and simply go through the file until it found the record the user wanted. Sorting the file would speed up the search because one could use various search algorithms to improve the speed of the search. Sorting the file would speed up the search, but in a dynamic application, it rarely made sense to sort a file every time a new record was added. The larger the file got, the slower the process was to sort it. And also, the greater the number of data elements or attributes in the record, the slower the sort would be. So the solution was to create an index file. The command in DBase would have been index on part no to parts, meaning to index on a data element or a field called part no to another file, an index file called parts. Parts would have been a totally different file that actually only had two data elements, the part no attribute that matched the one in the main file, and another data element that held the record number or a physical value in the underlying database structure pointing to that record. Anytime a new record was added to the main file, a record would have also been added to the index file. And then the database software would have immediately sorted the index file. Using those two files together made searches by part number much faster. Okay, why don't we take a break here? Go ahead and answer your mystery word. Go out to coursework and let's check our knowledge on the material we covered in this video. And when you're ready, come on back and we will move on to segment 3 of our series of videos on database system concepts and architecture.